Hey everybody, what's up? It's Jake from Nevis DevOps, and I'm going to finish this last section by going over the Itertools module. So, um, let's just get right into it. There's a whole bunch of things you can do with this, but I'm just going to show you some pretty popular ones. So the first one is going to be an infinite, and I'm going to say from Itertools import count. And then for n in count 5, 3, if n greater than 20, break. And then outside of that, I will say print n, and end equals a comma and a blank space. So this is just instead of new line, comma, space. Okay, so what in the heck does this do? I'll show you. Python, itertools, not iterate multiple sequences. I want to Python itertools. There we go. 5, 8, 11, 14, 17, 20. So what on earth does that do? Well, it iterates through numbers for n and count, which is just essentially counting up from 5 and 3 and up to the number 20, as long as n is if less than 20, or until n is greater than 20, or until n gets to 21. So what is the 5? So it starts at 5, and then it basically just keeps adding 3. So that's essentially one way. If you need to start at a number and go up by some step value, in this case 3, you can do that with itertools very easily and clean your code up, and there's just really not much to it. So I'm going to take this as a function, and I'm going to say define iter underscore count, and then put all of this over there like that. And then I'm not going to call it, so we can keep messing around. Okay, so that would be like an infinite iterator. It would just infinitely do this, and I could make it 100, and it will do the exact same thing as long as I call it. So if I called iter count, and it would just do this forever until it reaches this and breaks. So that would be starting at 5 and counting by 3. You may think that's a silly example, but this is actually quite useful. So the next thing we're going to do is iterators terminating on the shortest input sequence. Okay, so iterators terminating on the shortest input sequence. Okay, so in here, I'm going to import count, but I'm also want to import compress, right? So let's say I do the same thing, count, compress, and then here I'm going to say, let's say define iter compress, and then go, let's see, data will be a range of 10, and then I'm going to do an even selector, which will be a list 1, 0, and then times 10. And then I'm going to do an odd selector, which will equal 0 and 1 times 10. And then I'm just going to say even numbers equals a list of, and then I say compress the data and even selector. And then the odd numbers will be another list, and I will use compress again with data and odd selector, just like that. And then at the end, I will just print, let's print our odd selector so you can see that. And then we're going to print the list of data. And then we'll print our even numbers, and we'll print our odd numbers, like that. Now, in here, I'm just going to call intercompress and run it. Boom. So we can see here, here's our odd selector, and then we have our list of data, 0 through 9, and then my even numbers and my odd selectors, or my odd numbers, not my selectors. So notice that odd selector and even selector are 20 numbers in length. See 0, 1, 0, 1, 0, 1, it just goes back and forth. It's 20 elements in length, while data is only 10. So compress will stop as soon as data has yielded the last element. And it's a very fast and convenient way of selecting elements out of an iterable. It's simple, but instead of using a for loop to iterate over each value that's given back the compress calls, we use list, which does the same, but instead of executing the body of instructions, it puts all the values into a list and then just returns it. So yeah, that's it for that part. And then the last thing I think I'll do is some permutations. And I'm going to get rid of this function call. And we're going to do something called combinatoric generators. Super fun. These are really fun if you're into this kind of thing. I guess I am. So we're going to look at a simple example on permutations. So permutation is also just an arrangement of numbers, or order is an arrangement of elements in an ordered list into a one-to-one correspondence with itself. So for example, permutations of how many different versions of ABC are there? Well, there's ABC, and you have, let's see, ABC, ACB, BAC, BCA, CAB, and CBA, right? Something like that. So these are all permutations of ABC. So if a set has like an n number of elements, then the number of permutations is n factorial. So in this case, 3. So 3 factorial would be 1 times 2 times 3, which would be 6. And I can see 1, 2, 3, 4, 5, 6. So I know that these are all of the permutations of ABC because it's 3 factorial and I have 6 objects or elements. So let's check out how would you do this programmatically. So I'm going to define iter underscore perm as a function, and I'm just going to say let's import from this module also permutations, and you can just, instead of, I don't want to just import all of itertools, so I'm just pulling in these 3 and you can separate them with commas if you're wondering why I'm doing that. Okay, so all I need to do is go print list permutation, no, parse permutations, and then give it something, ABC. And that's it. That is literally it. And then we can just go iter perm to call this function and run it. And there you go, ABC, ACB, BAC, BCA, CAB, CBA, 6 permutations. That's all of them, 3 factorial. So this is super powerful. If you're doing a lot of iterations, yeah, this got auto-generated when I had a typo. If you're doing a lot of permutations, Iteratools is an amazing module that you can use and import different libraries and functions from this module so that you can do things like iterate over ABC. If you were to do this and type the code out yourself, it would be a lot more complex, and so you can save yourself time when you start to get to a little bit more experience and be able to actually list these things out very, very, very easily, short, concise, with just modules. Be very careful when you play with permutations. The number grows at a rate that is proportional to the factorial of the number of the elements you're permuting, and that number can get really big really fast. So if you're like, hey, that's cool, let me do my name, right? And you just do your name. Well, the difference between 3 and 4 factorial is 20, the difference between 6 and 24. So if I were to run this, all of a sudden now I have a lot more elements in this list. And if you're like, oh, let me do my last name, well, 8 factorial is a very big number. And you can see that this is very large and it's still running. It's taking forever because it would be 1 times 2 times 3 is 6, times 4 is 24, times 5 is 120, times 6 is 720, times 7 is 1540, times 8, which is 8,000 plus 12,000, plus 320, 12,300, something, some number like that. Uh, Elements of a list, each having 8 indexed objects inside of them, and this is still running. If we looked at my computer right now and see, let's look at what's going on as this is running. We can pull this over. Now, keep in mind, I have 64 gigs of memory and a pretty powerful CPU, but we can see right now the performance. Make this bigger. Where is there we go. My memory, you can see here, went all the way. I'm at 24 gigs right now. It just like jumped up because it started. But if I'm monitoring this closely, and we can see, okay, so I'm using 24 gigs of memory right now. What happens when I run this program? Well, let's try it one more time, even though it's going to make my computer angry. So I'm going to run this, and there it goes, and let's see what happens. So I'm at 38%. My CPU is sitting at 27-ish%. So 38, 28%. If I stop this, I kill it with Control C. If you ever do something like an infinite loop or you do something you don't want to do, it may take a second to respond because the computer is going to process these in order, and that command may not come in. It may not get that until later. Then you can see the difference. My CPU jumped up at 38%. Memory's at 38%. So we're going to see what is the CPU when this is done. So you can see here it's chugging along. And I've got other stuff running on here. There's some like background applications updating and other things. But there, okay, so it's done. So let's watch my CPU. Because the CPU is running through this. It's storing all this in memory, but the CPU is the one that was getting hit the hardest. And again, I have a pretty powerful computer, so it didn't really do much. It went down a little bit, but you can see this running pretty significantly, and there's some tools that you can also use to look at how much memory and CPU your application is using while you're running your code, to kind of see, hey, if I use this version, is this version better, or is this other version of the code that I wrote better, and see which one's more efficient. So anyways, that is it for the Iteratools. We went over infinite iterators, iterators terminating on the shortest input sequence, and also combinatoric generators using permutations, which is pretty cool. And you learned a little bit about factorials. So hopefully this, and combined with all the other scripts examples that I provided throughout this section of conditionals and loops, that you have the core foundation of Python programming. So for my sysadmins, you have a pretty big arsenal now of things to answer any of the questions that you may encounter. If you'd like to keep going, feel free to do so. In the next section, I'm going to be building out functions, and it's just going to be a whole section about functions, where I'm going to go over the building blocks of code chapter of this book and find out whether or not this is good. So let me know what you think, and if you have any questions, as always, let me know, and I'll see you in the next section.